Alright, so question 2. We've got three vectors. We got A, we got B, and we got C. A is negative 3i plus 4j. B is 2i plus j. And C is 3i take 2j. Question A just asks for a unit vector in the same direction as B. So we're going to take B and we're going to divide it by its magnitude. So we're going to take B and we're going to divide it by its magnitude. And that's going to give us B with a hat on it, also known as B hat. So let's see, let's do our magnitude. So over here we have 2 squared plus 1 squared. The square root of that is going to be the square root of 5. So therefore B hat is 1 over the square root of 5, 2i plus j. Easy money. Now you can rationalize your surd into root 5 over 5, 2i plus j. So rationalizing the surd just means that the denominator doesn't have a surd in it. Any questions on that one? So it's what we did last lesson. Question B. Find a vector in the same direction as A but equal in magnitude to C. Alright, so
Isn't that safe?
sorry, B says same direction as B but equal to magnitude to A. So we already have the unit vector of B, that's this guy here, but we're going to multiply it by the magnitude of A. So let's find the magnitude of A. 3 squared plus 4 squared. As we know, that's 5. That's our 3, 4, 5 triangle. So therefore, you do the magnitude of A multiplied by the unit vector B. So we're going to have 5 over the root of 5, 2i plus j. Can we simplify that?
If you root 5 over 5.
So we're going to multiply this by 5.
Yeah.
So we've multiplied 5 by this. Now this can be simplified because 5 divided by root 5 will just give me root 5. So in other words, I can go 2 root 5i. Yes. So I'll just explain in a little bit. So 5 can equal root 5 times root 5. So 5 over root 5 is root 5 times root 5 over root 5. These two can cancel out and I'm left with root 5.
Yeah.
Everybody see that? So this is my answer for B, or not to B. Question C. A vector in the same direction as A, but equal in magnitude to C. So first we're going to take A, and we're going to get the unit vector of A. Well, we know the magnitude is 5, so we're just going to divide our vector A by 5. So that's negative 3 over 5i plus 4 over 5j. Equal in magnitude of C. So we need to find the magnitude of C.
Just leave them all over 5 ourselves.
You may, yes, you may leave it like this if you wish.
Yeah.
It means the same thing. So now we're going to find the magnitude of C. 3 squared plus 2 squared, the square root of that. Plus what's 13. Square root of 13. And all I'm doing is multiply the magnitude of c by a hat. And that's root of 13 over 5 times 3i plus 4j. Okay. Just like that. Now 2D, a little bit of flavor now. We've got some chocolate sprinkles on our soft serve vanilla cone. So it's a vector in the same direction as the resultant of A, B, and C, but equal in magnitude to A. So once again, how do I find my resultant normally? Yes, Brendan? Yes, I would add my vectors. So I would literally, for D, to find the resultant, add my vectors together. A plus B plus C. Add all the i's and then add all the j's. Negative 3 plus 2 plus 3 is 2i. 4 plus 1 take 2 equals 3. So my resultant has a I component of 2 and a j component of 3. So that's the direction, but we have to make that a unit vector. So we'll just call this R for resultant. Oops, sorry, that's not meant to be there. Now I want to find R hat. So R hat's going to be, first I need to do my little magnitude, 2 squared plus 3 squared, the root of that. That's the square root of 13. 2i plus 3j. What's left? So that's one unit. It has to be equal to the magnitude of A. The magnitude of A up here we've already done is actually 5. So we're going to now times R hat by 5, because that's the magnitude of A. So this is that. So 5 over root 13, 2i plus 3j. Questions? Clarifications?
And then we just rationalize that as well.
You can rationalize it, yes.
So we need to.
Yes, to get the most simplified form. So 5 root 13 over 13, 2i plus 3j.